Hello viewers, welcome to BakoMaths. And today's lesson, we'll be looking at implicit differentiation, where we will be given an equation and we will be asked to prove for its differential equation. And a clear example is what we see here. It says that if y is equal to 5 divided by 1 minus s squared all exponent 3, show that 1 minus s squared all exponent 3 dy dx is equal to 6 sy. So we have our solution as this. Now in the question, we're given y to be equal to 5 divided by 1 minus s squared all exponent 3. Now looking at it, we can see we can apply the quotient rule because they are being divided, and applying the quotient rule to differentiate, we may also end up getting the solution just like the question demand. Yes, that is correct, but we can also make it easy by clearing the fraction and then also differentiate the result implicitly, of which you can also manipulate to get the proof just like the question asks. So here we are going to clear the fraction by cross multiplying. So when we cross multiply these two terms here, then we have now y multiply the denominator here, that is y multiplied by, so let's put that in a bigger bracket, that is 1 minus s squared exponent 3. And then we can clearly see that this y is being divided by 1. So 1 multiplies 5 gives us 5. Now we have this. Now the next idea is to differentiate all the terms here. So we differentiate them implicitly. So we start from the left hand side. From the left hand side of the equation, we can see that there is a y term here and then there is a term in the brackets. Now we can see that they are multiplying. So multiplying in differentiation implies we have to apply the product rule. Now looking at the function in the bracket, we have into bracket 1 minus s squared all exponent 3, which implies we have to apply the chain rule also in differentiating this. Why? Because 1 minus s squared is one function, and then there is another function of which is being raised to 3. So this becomes a function of another function. So because 1 minus s squared all exponent 3 is a function of another function, then we apply the we apply the chain rule. We apply the chain rule here. So having known this, then we find the product of the terms y and that of the term in the bracket by applying the chain rule to the term in the bracket, that is 1 minus s squared all exponent 3. We differentiate it by having in mind the chain rule. So here, in finding the product for this, we maintain y, that is y maintained, and we differentiate the function in the bracket. Now because it's a function of another function, the 3 here will multiply 1 minus s squared. So that gives us 3 multiplied by 1 minus s squared. Now we subtract 1 from this exponent 3. That gives us 2. We are not done. We multiply it by the differential of the function in the bracket, that is 1 minus s squared. So when we differentiate 1 minus s squared, we have minus 2x. Now we are done differentiating the function in the bracket. So we close it as such. Now once we are done, we can see that we are left with the differential of y, because in the first place we maintained y and differentiated this. So we continue by saying we differentiate y and maintain that of 1 minus s squared all exponent 3. So here we have the differential of this y gives us the y dx, and then we maintain that of 1 minus s squared into brackets all exponent 3. We continue to the right hand side of the equation, and 5 is a constant, so the differential of a constant gives us 0. So we have is equal to 0 here. We continue our solution here by simplifying what we have here. So it means simplifying whatever is in the brackets at the left hand side, that is we maintain y, and then we can see that 3 multiplies minus 2x gives us minus 6s, of which it multiplies 1 minus x squared all exponent 2. We close our brackets, and then we have that of 1 minus s squared all exponent 3 dy dx, which is equal to 0. Now that we have been able to simplify it, we have to manipulate this. We have to manipulate this solution or this answer in a way that it will represent what the question demanded. And the question said that we should simplify our answer in this form. That is 1 minus s squared all exponent 3 dy dx is equal to 6sy. So we have to simplify or leave our answer in this form. So you continue, we can see that there is a 6xy here. So coming back to our solution, at this point we can continue by multiplying the y by 6. That gives us minus 6sy, of which it multiplies 1 minus x all squared all exponent 2, and then we add it to that of 1 minus s squared exponent 3 dy dx. We can also remember that in the question we were asked to leave it in such a way that the 6sy be at one side, and then that of 1 minus s squared all exponent 3 dy dx also comes at one side. So here we can say that 1 minus x all squared exponent 3 dy dx is equal to, so when you transpose this to the right hand side, gives us 6xy multiplied by 1 minus x all squared all exponent 2. Now we have to make sure that the 6sy has no coefficient, just like the question said. So in this case, we continue by dividing both sides of the equation by the coefficient of 6sy. So we can see that the coefficient of 6sy here is nothing but, so this repeated, so the coefficient of 6sy here is what we have as 1 minus x all squared all exponent 2, and then we also divide here by 1 minus s squared all exponent 2, with the idea of eliminating the 1 minus s all squared. So here we can see that this will cancel that, and then we'll be left with 6sy. And here we can see that 1 minus x all squared exponent 2 can cancel that of 1 minus x all squared exponent 3, leaving the numerator 1 minus x all squared. So here we can see that these two will cancel that of this 3 to be left with 1 of 1 minus x squared. So here we have 1 minus x, sorry, so let's write it properly. So here we continue by saying 1 minus x dy dx is equal to 6xy. And finally, we have the solution as demanded by the question. So for y is equal to 5 out of 1 minus x all squared all exponent 3 can be differentiated for us to have 1 minus x squared, I think there should be a squared here, 1 minus x squared dy dx, which is equal to 6sy. So now we have it as the question demands. Now, having known this, let's try one similar example on implicit differentiation, which has questions of this form. So this is example 2 for today's video. Kindly subscribe if you haven't, you like, and don't forget to comment as well. You can try this by pausing the video and later resume to check the solution as I also solve along. So I have my function or my question as y is equal to 15 divided by the square root of s cubed plus 1. So you want to show that the differential of this is equal to what we have here. So in instance like this, just like we did earlier on, we have to clear the fraction by cross multiplying. So in cross multiply, that gives us y being multiplied by the function into brackets square root of s cubed plus 1 which is equal to 15. So once we have this, we can see that we can change the square root sign as an exponent, knowing very well that square roots can be changed to have an exponent of half. So here we have y being multiplied by s cubed plus 1, all exponents half, and then we equate to 15. Being able to do this, the next idea is to differentiate all the terms we have here. So we differentiate it implicitly. Now looking at the term at the left hand side, we can see that they are multiplying. That is the y term being multiplied by the function in the bracket. So we apply the product rule. Now in applying the product rule, looking at the function in the bracket, it is a function of another function. That is the function s cubed plus 1, one function, which has another function as exponent of half. So in instances like this, we differentiate it by applying the chain rule. So in this case, that is the term at the left hand side. We differentiate it by the product rule and also differentiate the function in the bracket with the idea of chain rule. So we continue our solution by applying the product rule. That is, we maintain y and then we differentiate the function in the bracket. So in this case, the exponent half will multiply s cubed plus 1. So that gives us half multiplied by s cubed plus 1. Now we subtract 1 from the exponent half. That gives us minus of half. We are not done. We multiply by the differential of the function in the bracket. So the differential of s cubed plus 1 gives us 3x squared. We also know that differential of 1 gives us 0. So we don't write that. Now we close our brackets. Now in the first instance, we maintain y and we differentiated this. So the next thing is that we are going to differentiate y and maintain what is in the bracket. So we continue by writing plus. So the differential of y gives us dy of dx, and then we maintain that of s cubed plus 1 exponent of half. Now we know that the differential of a constant is 0. So differential of 15 gives us 0, which is equal to 0. Now once we are done, we have to expand the bracket to make sure that at the end we leave our answer just like is being demanded by the question as such. So we go back to expand our solution. That gives us, so multiplying the function in the bracket, that gives us y multiplied by, so 3s squared multiplied by half gives us 3 on 2 s squared being multiplied by s cubed plus 1, all exponents of negative half, plus dy dx being multiplied by s cubed plus 1 exponent of half, which is equal to 0. At this point, we continue by simplifying it this way. We can see that y will multiply everything in the bracket, so that gives us 3s squared y on 2 being multiplied by s cubed plus 1, all exponents of negative half, and then we continue by writing plus of dy dx being multiplied by, so at this point you can see s cubed plus 1, all exponents of half, which is equal to 0. So we want to eliminate the denominator 2. That is, you multiply through by 2. So when you multiply through by 2, we can see that this 2 will cancel the 2 we are multiplying. That gives us 3s squared y now being multiplied by s cubed plus 1, all exponents of negative half, and then when 2 multiplies this, that gives us 2 multiplied by s cubed plus 1, all exponents of half, dy of dx, which is equal to 0. So which is equal to 0. And at this point, we can see that we have to transpose this, that is 3s squared y, to the left hand side so that it meets the solution for the question. So here we have 2 into bracket s cubed plus 1 exponent of half dy dx dy dx, which is equal to, so when we transpose this to the left hand side, it gives us minus 3s squared y multiplied by s cubed plus 1 exponent of negative half. So once we have this, we can continue by saying that, just as the question demand, the question says that the coefficient of minus 3s squared y should be 1. That is, there shouldn't be any coefficient. So it means that we are going to divide both sides by the coefficient of that is s cubed plus 1 exponent of negative half, and also divide here by s cubed plus 1 negative of exponent of negative half. So here we can clearly see that this is going to cancel that, and at the end we are left with minus 3s squared y. Now we can also see that in simplifying what we have here, the base are the same and they have exponent of half and exponent of negative half. So in that sense, since the base are the same, we add the exponent. So we get an exponent of 1, which means our solution now becomes 2 multiplied by s cubed plus 1, and then it has an exponent of 1, so we leave it. That gives us dy of dx, which is equal to minus 3s squared y. So this becomes the solution to the question, just like the question wants us to prove. So hence we can say that, therefore we can say that our y, which is equal to 15 divided by the square root of s cubed plus 1, can be differentiated as this. So this becomes the solution to the question, and we are going to end today's video here. And so thanks for watching. Kindly like, comment, subscribe, and share. Do not forget that this is BakoMaths, thinking beyond infinity.